We're learning Go. Last time I was at the for loop, so let's find it. Okay, types. I forgot about types. So okay. If okay, if statements. If statement. Okay, I'm gonna war. If with a start with a short statement. Okay, so if with a short statement. If and else. Okay, this is goofy. Switch statement. Switch. Mm, mm. Okay, let's write a switch statement. Get rid of this stuff. Okay, switch keyword. We have a variable which is implicitly assigned runtime GUOS. Runtime GUOS. So let me just print it. So what do we get? So fmt print ln runtime GUOS and do run Windows. What the hell? Default. So we get a string from this switch. So this is just like for if statement, we can add short statement after it, which is like declaring a variable runtime GUOS and close it. OS returns a OS. Apparently, what is this? Is this a return type or something? What is that? Okay, case Darwin fmt ln Mac OS. Okay, what is this? Mac OS. Case Linux. FMT println Linux. Default. So what kind of syntax is this, bro? So yeah, they're using the farmer specifier and OS. Okay. Printf. Okay. My problem, like here, what's the thingy? What's the variable need after short statement in switch? Okay, I did not start the timer. Short statement expression, so this is the variable that is being compared. All right. Anyway, that's pretty. And switch evaluation order. Switch I. Okay, run. Yo. Print FMT. Print L N time now. What is going on, bro? Okay, so when's Saturday? Weekday? Weekday. What do we get? This goofy motherfucking time Saturday. Today 0. Today 0. Today 1. Okay, so when you get a weekday, you can add a number to get the next weekday. This is some sort of like a freaking date time package. Okay, time package. Next, bro. So essentially, they're just time package, bro. Switch. Get out of here, man. If then. Hour is less than good morning, good afternoon, good evening. A differ statement differs the. Okay, let's run this. Differ. All right. First, we need to return this like f print ln. So this is gonna run first if we use differ fmt print ln world. Runtime imported not used. Get out of here, man. Hello world. Great. Oh, stacking differs. Last in, first order. So counting. First, they are printing counting. So let's print that. Print ln counting. Very easy. For I variable declaration, I condition, increment. No need for the parentheses. Is that what it's called? Differ fmt print ln I and fmt print ln done. So it should first say counting and then done and then print 1099, something like that. What the heck? Oops, my bad. So the condition never becomes true. What? I range 10. Bruh. Range 10. So 0 to 10, I guess. Pointers, bro. We're fucked. The type is a pointer to a t value. Nil. Right. So this pointer and asterisk, t is a type. So p was the integer pointer operand, and pointer generates a pointer to its operand. So assuming this gets the value, right? Or it says pointer. So we get a pointer. Shit, man. So we get the pointer. Jesus Christ, this is the value of the pointer. We're assigning the value to the pointer. Dereference indirecting go as no pointer arithmetic. Shibal. Okay, let's do it. So create two variables. Okay, wait a minute. I create ij and j as implicit, like 20. Okay, 0, 1. ij 40. What is wrong? Declared but not used. Okay, fuck off. P points to I. Point to I. Read I through. FMT. Print ln P. Set I. P set it to 21. See the new. FMT. Print ln I. Point to J. Divide J through the pointer. Get the pointer value. We get the pointer value and divide by 37. FT and ln J. So we created two variables. This gets the, am I recording the pointer, bruh? Like properties. Okay, I'm recording the cursor. So I got two variables, I, J, implicitly setting values. And I get the address. I print the value from the address by using dereferencing it. Cool, okay. Seems pretty easy. Pointer struct. A struct is a collection of field. Okay, wait a minute. Create a pointer. Pointer. Dereferring. Referring. Okay, I don't know. And then create struct. A struct is a collection of fields. Whoa. Okay. So creating a struct, you need to use the type and then the name vertex and keyword struct. Capital letter for variables, it holds collection of fields. And then here fmt print ln vertex 1 2 field value. Okay, seems like an object struct for access using a dot. Ah, vertex fmt print ln vx. This is like an object, bruh. Struct fields can be accessed through a struct pointer. To access a field, fields can be accessed through a struct pointer. To access the field x of a struct, when we have the pointer p, we could write. However, that node is cumbersome, so the language permits us instead to write just px without explicit dereferencing it. However, that node is cumbersome, so the language permits us instead to write just px. Okay, so assuming this, like, so we got a value, we create a pointer that points to v. So now we hold the address, and now we can print ln. So printing is simple as this. We don't need to use the asterisk p surrounded by parentheses and dot x. fmt not br. What do we got? Print. Okay, took a bit of time. A struct literal denotes a newly allocated struct value by listing the values of its field. You can list just a subset of fields by using the name syntax and the order of the special prefix and return a pointer to the struct value. As type struct literal. I am assuming this is struct literal. Whoa, var. We can declare variables like this. Var per as type vertex y just, you can list just a subset field using the name syntax. As type vertex. Okay, so variables, let's create them. Here I can use the var and parentheses to create multiple variables inside of it, and I can use the explicit name assignment. So this is a struct literal or something. So this is the basic way to do it. Another way to do it is just pass in the value you are just interested in. I want to pass only variable x, so I'm going to use x and colon 1. And now assuming right, if my intention or hypothesis is correct, I can just if I print it, the y value should be 0. Like print. What is going on? Okay, that is the inside variable, so we don't want that. fmt print ln v2. Yep. So this is one way to declare a single field. You can obviously just create like this and leave out, let it give it the default value. Go assigns default values for everything. And this is a pointer to the struct vertex. Okay, next arrays. We are going through it, speeding through it. Okay, let's now check out arrays. So yeah, we got a variable declared, and this is the array. So this array contains 2 elements and the type is string. So declare it by var variable name, a brackets, how many elements, and the type. And access assign a value for the first index, index 0, hello. Second index, index 1, world. FMT print ln, and then a 0, a 1. Should say hello world. And what if we print fmt print ln just the array? So we got this. There's no comma, bruh. There's no comma between these two values. So here we are creating a primes variable, although we are not using the var keyword. Okay, that's what this does. So 6 elements, type is integer, 1 2 3 4 5 6. Okay, great. Slices. All right, slices. All right, we are checking out slices. This is one of the difficult shit. I keep forgetting how to slice arrays. An array has a fixed size. A slice, on the other hand, is a dynamically sized flexible view into the elements of an array. Slices are much more common than arrays. The type is a slice with elements of type T. So apparently this type is a slice, and a slice is formed by specifying 2 indices, a low and high bound separated by a colon. This selects off open range, which includes the first element but excludes the last one. The following expression creates a slice which includes elements 1 through 3 of A. Okay, so off open range. All right, let's read variables real quick. So we get primes. Primes, just omit the var keyword because we are using this syntax. 6 elements of integer type and 2, 3. Use the braces to instantiate it. 1, 2, 3, 4, 5, 6. Okay. Now we just create a slice. Vars as of type int. This is apparently a slice, and I want primes. Primes 1, 1, 2. Start from index 1 here and get end at 4 index. 1, 2, 3, 4. So it's gonna, if I use 4 here, it's gonna say get 3, 4, 5. Okay, that is use a colon and print empty, print ln and s 3, 4, 5. Great. Slices are like a reference to arrays. Store any data, it just describes a section of an underlying array. Changing the element of a slice modifies the corresponding elements of its underlying array. Other slices that share the same underlying array will see those changes. So arrays and slices. Okay, wait a minute. Are array slices in JS references that mutate original array? Okay, so slices kind of mutate the original array. A slice does not store any data. Okay, we know that. Okay, so names. Let's create names. Names. 4 names. Ring. Just copy this for now. Random shit. I don't need that. Shift Alt F. Okay, print names. So why would I do that? Names. Okay. Let's change the first name to something. First, let's copy it. Okay. This is yeah, we could like write like this, but again, we can use the implicit type names. We get the names, get the first element. Yeah, we get the first element, and let's print it. fmt print ln a. So we should get only one element. Okay, my bad. John. Okay, here I'll just get the first element and assign it my name. Also print ln. Also vmt print ln names. Great, we modified the original array. Slice literals. Slice literals like an array literal without the length. This is an array literal. So 3 bool true true and this creates the same array as above, then builds a slice that references it. What the hell is this? Slice literal is like an array literal without the length. So a slice literal, it does not have a length property. So this is array literal, this is a slice literal. So Q, so undefined length, so Boolean struct. What the hell is this syntax? Oh, it's a slice of struct. It does not anonymous struct. Does not have a name. All right. Doesn't have a length. Can I push values to it? Append. Length versus capacity. How much space before we go allocates reallocates memory? So this is wrong. You must reassign because append may allocate a new underlying array. Fixed array slice. Size locked forever cannot append. Dynamic can append multiple values. What the hell? Append another slice. Okay. First the sliced elements. Jesus Christ, that's very weird. Okay, let's create a slice. Slice is just like an array, but it does not have length. So create Q, an element. So don't use the length for it. And boom, we just created an array. What happens if I have the same element? Shouldn't do anything because arrays do not enforce any sort of limit. So this is a slice. I can do Q append 1 2 3. Okay, bullshit. And then fmt print ln Q and some bullshit values. Okay, that's how you had values. So yep, so we created integer slice. This is a boolean slice. This is a struct slice. Struct. Okay, cool. Let's create a struct again. What's the value? I believe I used, what the hell? I don't know, dude. Let's say vector struct x int y int. So this is a struct. Wait a minute, let's go back to, okay, type. We need to use a type, bro. Also can't use that goofy colons. All right, this is how we create struct, but slices are different. Use it like this struct, and then values 1, 2. Wait a minute. You need to define int bool to true. Assign the value to something. Use it. What is going on? Expected declares found as syntax. So I am using the same thing, right? What's going on here, dude? Real problem. Found S. Let's get rid of it. Maybe we can only declare it in the main function. Like, what do we need to do? Don't understand it. What's wrong? Sheet multi-line needs a freaking, yeah. Apparently just get rid of it and put it like this, 1, 2. But what the hell, dude? Okay, boolean true. Multi-line is way more readable. Get out of here, bruh. Slice defaults. When slicing, you may omit the high or low bounds to their default instead. The default is 0 for the low bound and the length of the slice for the high bound. For the array, length of the slice. Okay. For the array, so array contains 10 integers. The slice expressions are equivalent. 0, 10 start from 0 and at the 10th, and the same thing, bruh. So this just gets all the elements. What's the fucking point of it, bruh? Just copy it. Slice length and capacity. Slice length and capacity. A slice has both a length and capacity. The length of a slice is the number of elements it contains. The capacity of a slice is the number of elements. Capacity slice is the number of elements underlying array counting from the first element in the slice. The length and capacity of a slice can be obtained using the expression length as, len as, and cap as. You can extend a slice length by reslicing it, provided it has sufficient capacity. Try changing one of the slice operations in the example to extend it beyond its capacity. See what happens. So this is a slice. Slice. Let's print it. Tired of this shit. Print slice. We don't have a print slice function. What is this function? Func print slice takes as. So this is the type that gets the slice and fmt print ln says length is equal to is the value, so we are print format length is replace cap is and s some sort of value. What is this value, bruh? So format specifier len as cap s and then s. Let's run it. So length, so this is the length of the array. So length is 6. Extend its length from 0 to slice 4 element. What is this? Extend. How does this extend length? Yeah, we can extend it because we have 0, but the capacity is still 6. Length is 4. Wait a minute. Gets the first 3 values based 4 values. 4 values basically. Drop. Why does the original slice still persist even after reassignment? Slices are not actual data, they're just small view pointing to one underlying array. Slice array is basically pointer underlying array length capacity. So this does not delete data, it only changes length to 0. That still exists memory. Underlying array s points here 6. Now it's still points here. That still exists. Just pretend there are 0 elements. Because capacity is still 6. Visible slice becomes 10 moves. Slices are views windows into array. They do not want memory. That's why modifying one slice can affect another slice sharing the same backing array. Because both slice pointers are. But what if I get the slice and I append another bullshit large number? Print slice s. We just increase the slice. So we can only increase the length by appending it. Who would have thought? Okay, nil slice is up. The 0 value of a slice is nil. So apparently the slice can be nil. So if I instantiate a slice as with type slice fmt print ln, this takes the slice, print the slice, print the length, print the capacity, cap s. Now should say nil, right? Okay, it doesn't say nil but says empty. But we can check if s is nil, some sort of keyword, default keyword, print ln nil. Okay, creating a slice with make. Dude, what the hell? I'm just learning slices and slices. Maps, map literal, mutating maps, function. Jesus, methods. Methods are pointer index, choosing a value, interfaces. Interface values, nil interface, empty interface, type assertion, type switch, string. Errors, readers, read images, congratulate, type parameters. Holy shit, where are we? Type parameter, we are in the type parameter, generic types, concurrency. Shit.